Hello, my name is Josh Obrecht, and I'm a GIS analyst with the ACPF National Hub. In this video, we're going to discuss the Drainage Water Management tool. This is the third tool in the Precision Conservation Siting Practices section of the ACPF Toolbox. The Drainage Water Management practice adjusts the water table at certain times of the year via control gate. So, for example, if field access is necessary, say for harvest, the gate can be opened to allow unrestricted drainage. Or if you're in the midst of growing season, the gate can be raised, which will raise the water table and therefore the water available to plant roots. One control gate can influence the water table within approximately half a meter change in elevation. The way the ACPF tool works is that they will only be sited within agricultural fields. Those are fields with an is-ag value equal to 1, and if the field is likely to be tile drained based on the tile drainage classification tool results. The user can also define the contour interval that is used. When a gate is suggested for a half-meter elevation change, if you were using a 1-meter contour interval, that means 2 gates would be suggested for that interval. The user can also specify the minimum acreage size the interval must make up of the field. In ArcGIS Pro, we will open the catalog window in the right side of the screen if it isn't already open by clicking the catalog tab. Expand our ACPF toolbox and expand Precision Conservation Practice Siting. Double-click on Drainage Water Management to open. This tool has 6 inputs that it's asking for. The first is our field boundary feature class, and we can add that in the first dropdown as it is already in our map. The second required input is our unfilled DEM. That's our new DEM, which is also in our map, so we can choose that in the second dropdown. The drainage table has been automatically added as our third input. The tool also asks for a z-factor, so once again, we'll enter 0.01. We also have 2 inputs for which default values are provided. The first of these is a contour interval in meters. We will leave this at the default of 1. The last input is the minimum acreage within a field that the user-defined contour must occupy. We will also leave this at the default value of 20 acres. There is one output from this tool, a Drainage Water Management Polygon feature class, which will show us the area that would be treated if the practice was put in. Click Run to run this tool. It's kind of interesting how this tool works. We have an example where we have specified a 1-meter contour interval and that the user-defined contour must be a minimum of 10 acres of the field. So first off, the tool calculates the elevation range of each field. That range is then rounded appropriately, and the number of 1-meter contour intervals that can fit within that field is found. The field is then sliced up by those contours, and the slices are determined to be zones if they are greater than the user-defined acreage. So in our case, are any of these slices greater than 10 acres of the field? If it is, then that slice is flagged as an opportunity for drainage water management. There can be multiple opportunities per field. It just means that more control gates would need to be installed. The Drainage Water Management tool has just finished running. We can see that the result, a Drainage Water Management feature class, has been added to our map. Most of the opportunities produced are found in the flatter portion of the watershed because the steeper slopes don't allow for larger areas between the contours. By zooming in, we can see that within individual fields, the portion that would be treated by the practice. If we open the attribute table for Drainage Water Management by right-clicking on it and clicking on Attribute Table, we have the field boundary ID that's associated with the practice. This is beneficial as we'll be able to see if a field has more than one opportunity in it or not. Records 2 through 4 all appear to be from the same field, so that means that field has more than one opportunity. Then we have the contributing acres to that practice, and all the features should be above the specified limit we provided when we ran the tool. The total field acreage is also provided and is used to calculate a percent field value. The percenter field allows us to see which practices will allow us to maximize their benefit. If we sort this column descending by right-clicking on the field header and clicking on Sort Descending, we have a practice that is treating 90% of the field. If we right-click on that record and go to Zoom To, we have our practice shown within that field. We'll be able to see how that practice is situated within said field. And lastly, in the attribute table is the contour interval that will specify in the tool inputs, in case you forgot. To recap, we ran the drainage water management tool and discussed how these are calculated and used within the watershed. In the next video, we will run the next precision conservation practice siting tool, more terrain derivatives.